So this is what we need to keep in mind. A cannot otherwise be interpreted just like that. When x takes value 0, y takes a value whatever it is. There's one quick concept that we need to learn, and that is standardized regression. So I can get these coefficients standardized. Okay, that is, instead of regressing y on x, if I take y minus y bar upon sigma y, that is z of y scores, and I take x minus x bar upon sigma x, which is z of x, and then I write an equation that zy is equal to a plus b zx plus e. Then what I am doing, instead of using variables themselves, I am using the standardized convergence. Okay, so z will have a mean of 0, variance of 1, zy. Similarly, zx will also have a mean of 0, variance of 1. Now, there is in this case, since they have mean of 0 and variance of 1, your a will be a is equal to y bar minus bx dx bar. Y bar is 0 minus b into x bar is 0. So a will be 0. So in this case, right, you have a, which is x bar minus b, y bar minus bx bar. Now in case of standardized regressions, y bar actually is zy bar minus b zx bar, which is equal to, so we know when variable takes a standardized form, the mean of z is 0, b into 0, which is 0. So a is going to be 0 if we are using z's standard normal variable instead of the original variables. Okay, which means that your regression line will pass through origin. Regression line would pass through origin. Regression line then would always pass through origin. Now, can somebody quickly tell me what will be the interpretation of B if I take standard forms of variables? How would I interpret B if I take standard forms of variables? B is equal to covariance xy upon variance x.
That's one.
Okay, think something about the denominator.
So B will be equal to covariance xy, right?
Yeah, but what is covariance xy then would be?
Covariance is going to nothing is going to change. It will be correlation, right?
It will be correlation. It will be correlation. What is your correlation? Your correlation is Rxy is equal to covariance xy upon standard deviation x, standard deviation y. Now, for when I take z's, the sx is equal to sy is equal to 1, right? So, actually, the whole thing can be written as Rxy is equal to covariance xy upon sx, right? Which is covariance xy upon sx square. This is what is byx, right? So your covariance would be the correlation coefficient when you compute a covariance on standardized variables. Beta actually would be B that we compute, the OLS estimator B that we compute for standardized regressions are actually correlations between the two variables, right?